as a foundational physics student, can you understand how an MRI works? I think you can. So here is a very simple intuition. Now, of course, there's much more to it, but with foundational physics, this is as far as we can probably take it. So there's really just 5 components of an MRI that you see then, or that screen. And those components are, well, do you understand a magnetic field? Well, that magnetic field is caused by the machine. Do you know what a hydrogen spin is? Well, those are just water molecules in our body, which you can see here on the screen. If you take a charge and it starts to spin around, it creates kind of like a little magnet, like a compass. Then, do you understand that you can have radio frequencies, which you can shoot at these little protons or hydrogens, okay, and realign them? Finally, you can turn off the frequency, and all of a sudden, the magnetic realignment will be with the magnetic field. And then finally, because there's energy which is released, okay, due to the alignment with the magnetic field, we can capture this through an image, which we call magnetic resonance imaging. So that is it, okay, in order to understand MRIs. Let's dive into these components to try to understand them. So a magnetic field I won't understand. I can put up a link. Of course, you should know what a magnetic field is. And that magnetic field is caused by the machine. But what is this hydrogen spin, which is really something that we want to be able to understand? And once you grasp that, that is really as far as you can take it. And then you can learn much more if you choose to do so. So if you have a charge, now it doesn't matter what charge it is, we know in foundational physics that if you take a charge or if you create a current and you start spinning it around, so if you start spinning it in this particular way, we know that all of a sudden you're going to have, through this actual spin, a causation of a magnetic field. So this will act kind of like a magnet, okay, and it will act like a little compass. So you can think, okay, of this as that little compass. And why is that so? Well, remember that if a charge is moving, you can use your right-hand rule, okay, and if it's a proton, then you can see exactly, okay, where that would be. And that's why it's pointing upwards. Now, if we do have a little compass, and you put this little compass in a magnetic field, so coming in from the machine itself, it will align with the magnetic field of that machine, just like you take a compass around the Earth, and it will align with the magnetic field of the Earth itself. So now, if you dive into our bodies, well, we have a lot of water in our bodies. And because of that water, so we have H2O, so we have a lot of hydrogens now, so that means we have a lot of protons. So those particular protons in the hydrogen are basically this spin that we're just discussing right now. So if you dive that deep in, you have these little compasses in your body. Now they're randomly placed, but if you turn it on and place your body in a magnetic field, then all of them will start to align with the magnetic field. Maybe not all, okay, but most, at least in parallel to it. So if we think of it that way, then now all of a sudden, what we can do is we can start taking these, and what the magnetic resonance imaging does, it shoots a radio frequency at these little guys, okay, and these suckers get hit with it, and now they realign. So what happens, they will now realign and spin in a different way. So for example, you will take this, and I'm going to take these little compass, and you can realign them, and typically they will realign kind of orthogonal, okay, so perpendicular to what they used to be. So maybe in this way, or possibly maybe in this way. Doesn't really matter for intuition's sake. So now as they're realigning, well, they're no longer in the magnetic field direction that you have. Now, why is that so? Because we're giving it energy to and disturb it. So now that we have realigned this, now we turn off this actual frequency. And what happens is that in due course, all of these, because they're in presence in the magnetic field, well, so they've been given a certain amount of energy. And now if you turn it off, this will start to realign with the magnetic field that is in the machine itself. And as it realigns, what does it do? Well, it gives off energy. So it gives off energy that it was given by the RF signal. And that energy is basically your MRI, your magnetic resonance imaging. So it captures that energy, and depending on where it is in the body, what concentration it has, okay, if it's healthy, if it's unhealthy, okay, depending on what that will be, well, that will give a certain amount of energy. And then the magnetic resonance imaging starts to slice this up. Of course, there's many different procedures, and the engineering is incredible behind it. But, okay, that's the basics of how an MRI works. So you have a magnetic field which gets turned on. So you have these little guys that start to align with the magnetic field. So these are the protons from the hydrogen, because we have a lot of water in our body. Then we shoot an RF signal, so a radio frequency, to give it energy, and therefore it realigns these, okay, in the frequencies that it has, so kind of a resonance frequency of the actual RF signal. And then when it realigns, it gets a certain amount of energy. When the signal gets turned off, therefore this will now once again realign with the magnetic field, giving off energy, and that energy is what we capture in the magnetic resonance imaging. That is it. So as long as you understand your right-hand rule, you understand, okay, when a proton is spinning around, at least intuitively, okay, it creates these little compasses, and these compasses align in magnetic fields, and therefore we can use them to create these amazing MRIs. Now, the engineering is incredible, and I will put all the resources, okay, that you have towards and in the description of this video. All right, I hope that you understand some glimpse of the intuition into MRIs as a student of a first-year physics electromagnetism course. All right, thanks for watching. See you in a future video. Bye, everybody.